The function that we are looking at, I picked something simple for us to just use to visualize. We've got f of x equals x squared, which, yeah, that's a parabola. We're only looking on the interval 0 to 1. And the reason this takes up so much space on the paper is because I gave you all of the pictures. We're going to try to estimate the area between that graph and the x-axis, right, using rectangles. So for this first one, and for all of these, we're going to have 4 sub-intervals. So our interval is 0 to 1. We're breaking it up into 4 equal sub-intervals. Do you see that there? Like broken into 4 even space. Okay, so here's the first one. The height of that rectangle is 0. You still want to write it anyway so that you have a total of 4. I get that there's nothing that you're like, Miss Cole, there's nothing there. But you still want to have a total of 4, all right? Now, how could we get the height for this second sub-interval? Well, that says 0.25. I'm going to treat that like 1/4. All right, I like fractions better in this case. You would take that number and plug it into your function, which is just x squared. I kept it something really simple. So if you take a 4th and square it, you're going to get 1/16. Good, thank you for coming with me. We understand how fractions work, all right? This one is a half. If you square that, you're going to get... Perfect. Okay, cool. I don't have to stop teaching calculus and start teaching arithmetic. All right, and then this one is 3/4. If you square that, like plug it into the function, you're going to get 9/16. Okay. To get the area of a rectangle, it's base times height. What is the base, or meaning the length of the sub-interval? Yeah, and now we're going to do fractions. I'm sorry it printed as 0.25, but they're all 1/4. So we're going to do base times height. So the first one is 1/4 times 0. There's literally no area there. It's an unrectangle. There's nothing there, right? Plus, now when you do the second one, again, the base is 1/4. They're all going to be 1/4. And the height is 1/16. That's going to give us this area. I like how visual this is. You can just see it really nicely. All right, and then to get the area of the next rectangle, it's going to be base times height. 1/4 times 9/16. And oh, I'm sorry, I skipped one. No, that's wrong. It'll be 1/4 times 1/4. I'm sorry. I apologize. Oh, why isn't my whiteout working? Yeah. Sorry, this one right here, the height is 1/4. I apologize. Got ahead of myself. And then the last one is 1/4 times 9/16. I wrote that out the long way, but what would be an abbreviated or factored way you can do that? What is the GCF for all of them? Yeah, 1/4. So, and I'm going to skip that step in the other ones. So 1/4, and then you would add all your heights together. So 0 plus 1/16 plus 1/4 plus 9/16. Hey, Ms. Cole, why do you keep putting the 0? This is why, and I suggest you do this too. If there are 4 sub-intervals, which they have to tell you that in the problem, if there are 4 sub-intervals, you should have 4 numbers added together. It's a way you can check that you got them all. Do you get what I'm saying? So like keep the 0 in there. Now I wrote down what that is as a decimal. It is 0.21875. For the sake of time, I'm just telling you that if you put that in the calculator, that's what you're going to get. Is that an underestimate or an overestimate of what the true area under this graph would be? Under, because, well, do I need to explain that? Like obvious reasons, like you're missing a whole lot of it, okay? This is what's called a left sum. Why do you think it's called a left sum? Do you take the heights from the left side of each sub-interval? So this is going to be an underestimate if your function is increasing, which that's what this one is doing. It's going up. If you pull from the left side, you're taking what's lower down. It means your heights of your rectangles are coming from the left side of each sub-interval. You'll see when I do a right sum, it'll be on the other side. So it's an underestimate if your function is increasing. It's an overestimate if your function is decreasing. If you imagine a graph going down, do you have an imagination? If you imagine a graph going down, do you see how the left side would be higher up? Okay, so that would be an overestimate. Okay, I'm just acting it out with my hands and being silly. All right, let's try another one. We're just going to basically repeat that process. So let's go ahead and highlight all of the heights of our rectangles here. And do you see how they're on the right this time? Like, do you see that? They're on the right side. So I'm going to jump straight to the abbreviated version. Each subinterval is a fourth, but caveat for a second. You can only write it in that abbreviated way if all of your subintervals are uniform, meaning the same. If this one was a fourth and that one was a half and this one was an eighth, do you get how you would have to write it the long way? Like they're all different, okay? So it only works if they're uniform. All right, so what is the height for our first rectangle? We want to get this area right here. 1/16, good job, perfect. And then for the second rectangle, this one right here, it was 1/4. We did that in the problem above, so I'm just repeating it. All right, and then this one was 9/16. And then this last one, if you plug 1 into the function, which was just x squared, 1 squared is 1. So 1. Cool. If you plug that into a calculator, and I hope you all trust me at this point, I just typed it in, 0.46875. And so that would be a what? Yeah, overestimate for obvious reasons. You have all these areas hanging off of the edge. It's a right sum because you're taking your heights from the right side of each subinterval. This is going really well. Do you remember this from last year? Yeah. Riemann sum? Okay, cool. Okay, cool. Rectangles and stuff, okay? So it's going to be an overestimate like this one is if your function is increasing. It's going to be an underestimate if your function is decreasing. This is going really nice. I'm happy with it. Because this is one of my favorite lessons to teach, so I'm glad you're all on board. It's easy. And it's very real. It's very like, I can see these rectangles. I can see the areas. It's tangible, you know, it's like you can see it and touch it. Rates of change are very, I will not hide from you now that we've gone through it. I don't have much patience for derivatives. I don't like them very much. I feel much happier in integral land. So I'm very happy that we're now here. Not a super big fan of derivatives. All right, so this one, we're taking our heights from the center of each interval. So let's take a minute and have a conversation about the fractions here. Halfway in between 0 and 1/4 would be 1/8. And then you can kind of just count. Just watch me point to this. Me too. 1/8. 1/4 would be 2/8. So this next one is 3/8. A half is 4/8. This is 5/8, 6/8, 7/8. So you can just count once you get to that. It's like the unit circle, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, the whole way around. Okay. Now to get the heights, you're going to plug those into the function, which is x squared. Okay. Now here's the thing that does mess people up. Each subinterval is still 1/4 unit long. Do you see that? Okay. So they're all still a fourth. And so I can, factor out that 1/4. Now let's get our heights. If you plug 1/8 into the function, basically if you square it, you would get 1/64. Good. Plus, now if you plug 3/8 in, you would get 9. We're basically practicing our perfect squares here, really. 5/8 squared would be 25/64, and then 49/64. If you type that in a calculator, you're going to get 0.328125. I promise. Yeah, I wrote it up there. Sorry, I said it kind of fast, but I wrote. That's not super important. I just want you to be able to compare the numbers. It's kind of impossible to compare this with the other ones, but you saw one of them was 0.2, one of them was 0.4, now this one's 0.3. Okay, that's like what I'm getting at there. All right, this is called a midpoint sum. And I'm going to explain how you tell if it's an over or under. That is so unlikely to come up, so don't worry about it too much. But I always like to do the trapezoidal sum and then come back to it. So we'll come back to whether it's over or under. Just hold on. Just hold for a second. All right. The last one is trapezoidal. You do need to know this formula. So I don't know if you want to put some stars next to it. That's not going to be given. Your trapezoidal formula, it's 1/2. There's a 1/2 in the formula. The height. Now listen to me. All the trapezoids are on their sides. So the height is this. It's the length of the subinterval, which in this case is what? 1/4. Okay. The height is going to be the length of your subinterval. And then it's base 1 plus base 2. Let's go ahead and just draw those in again so that we have them. I know we did it on the other side of the paper, but just for the sake of being able to see it here, this one was 0. This was a 16th. This was a 4th. This was 9/16, and that one was 1. Just so you have them there, because we're going to use all those numbers, and I want you to be able to see where they're coming from. We are going to write this out the long way first, because I need for you to see how it all comes together. So this is like, you're not going to be happy. It's going to be about this long, but you're all going to survive. I sincerely promise. All right. So first one, a half, simply because it's in the formula. We said the height was how much? 1/4. Good job. And then you add the bases together. So for this first one, it would be 0 plus 1/16. Hey, Miss Cole, should we write the 0? Yeah. Because you don't want to feel like you missed part of the pattern. It's very pattern oriented, and you don't want to feel like you missed that. All right. 1 down, 3 to go. Next one, 1/2 times 1/4. And then add the bases together. So look, this is the one we're looking at now. So it would be 1/16 plus 1/4. Good job. Halfway there. Next one, 1/2 times 1/4. And then it's going to be 1/4 plus 9/16. Beautiful. And then one more. Let's just all write it and make sure that we all get the same thing, okay? Yeah, I ran into my graph. I told you it was going to be long. Just go down to the next line. I'm not collecting your notes. They're just for you to understand what's going on. That's the point of notes, okay? You can yawn. I just will mock you. I'm tired too. We're going to make it. This is going super quick. Like this is actually one of the fastest lessons. Good job, guys. Go us. This is like one of the quickest ones we've done this year because everybody's understanding. All right, let's write it the abbreviated way. What can you factor out of every single one of them? 1/2 and 1/4. If you said 1/8, you're not wrong, but don't write it that way. Again, this is very pattern generated. And if you lose part of the pattern, you can end up confusing yourself. So the 1/2 is there because it's in the formula. The 4th is there because it's the length of the subinterval. Keep it 1/2 times 1/4. But I don't want to. Okay, well then when you make a mistake, I'm going to mark it wrong. Right? Now watch me point to this because this is very visual. Do you see how the 0 and the 1 are only in there once? Okay, now look it. Do you see how the 1/16 is in there twice? And the 1/4 is in there twice? And the 9/16 is in there twice. That's because they are shared between the subintervals, but the 0 and the 1 are only in there once. Okay. I love when you guys do that. Okay. So it's going to be 0 just once. Yes, write it. Plus, and then you want to double the 1/16. You want to double the 1/4. You want to double the 9/16. And then the 1 is just in there once. So again, the ends are only used once. The ones in the middle get doubled because they are shared between the trapezoids. Is everybody on board with me? Shared, okay? Oh, do you remember this?
Yeah,
with the 2's in there?
I never. It makes much sense. A lot of sense how why it's actually doubled, but I did it last year. It wasn't.
Yeah. So do you see how the 1/16 you use it for this one and you use it for this one, but like the 1 only gets used once.
Yeah.
So, but you have to see, that's the thing is nobody really wants to write it out the long way. And I get it. Put the phone away. But the thing is, you don't see that it's there twice unless you write it out. Also, and foreshadowing, I have one on the other side of the paper like this, and it shows up like this on the AP exam. If these aren't all uniform, you have to write it that long way. All right. So buckle up, Buttercup. All right. So this one is 0.34375. Also, in case you didn't know, this is the average of the left and the right. So if you flip back to the previous page, if you don't believe me, if you average these two, like if you add them together and divide by 2, you know how to average things, okay? You will get this one. So if you average the left and the right, you get the trapezoidal, all right? 34375. Question, go ahead.
If we're asked on a test to do like a trapezoidal one and we forgot the formula, can we just
Do you write Adam divide by 2?
That's valid?
I think that's a lot more work in the exam's time is the only thing I'm going to say, but you'll get the right answer, and the right answer is a right answer, right? So trapezoidal sum. I'm going to over exaggerate this picture just off to the side. Let me grab a sticky note. This graph, is it concave up or concave down, our x squared? It's concave up. So look, if I were to like zoom in on this, if I draw in trapezoids, they're going to be very slightly where, over or under? Over, do you see that? Okay, so this is going to be overestimate. So it is an overestimate if your graph is concave up. It's going to be an underestimate if your graph is concave down. And I usually just draw this off to the side, like I'll over exaggerate the curve and then just figure out if it's above or below. So to go back to midpoint, this is so unlikely to be asked, but I'm just going to go over it to make sure we don't leave any stone unturned. The midpoint is simply the opposite of that. So I don't really memorize midpoint. I just think about what trapezoidal is, and then I'm like, okay, it's the opposite. So this one is going to be an underestimate if your graph is concave up, and an overestimate if your graph is concave down. Again, that's like okay, we covered it. You are probably not going to be asked that. It is like super, super unlikely, but I showed it to you. Right? We're not going to write anything for number 5. We're just going to have a conversation. I put it on there to generate a conversation. Are any of these estimates better than the others? Do you think there's one that's better? Do we like the trapezoid? Well, I mean, usually it's between these two. Does anyone like the midpoint sum better than the trapezoidal one? Okay. Yeah, I like the trapezoidal one better, personally. This one, I feel like, so if your graph only increases or only decreases, it can be pretty valid. What if your graph does something like this? It can be really off, in my opinion. So I agree with you guys. We are in agreement. What could you do to make the estimates better? Yep, more, and I'm going to call them sub-intervals because that takes care of whether they're rectangles or trapezoids. You just want more of them. I'm going to skip number 7. That's okay. That's one of those things I put more on here than we really need. We'll just jump to number 8. Okay. Use the 4. So 4, do you see that there? When you add things up, you should have 4 numbers in a row. I don't care if one of them's 0. Write it to make sure that you have 4 as a total. Okay. Also, we're going to circle our subintervals. 1, 2, 3, 4. Miss Cole, I don't want to circle them. Circle them. Circle them. Okay. 1, 2, 3, 4. Reading is important. What kind of sum are we getting asked to do? Left. Are your subintervals uniform? 0, 3, 8, 10, 16. You cannot write it in the abbreviated way. You have to write it the long way. Okay? You're going to be okay. What is the length of the first subinterval? 0 to 3. 3. Good job. That's the base. The height, what did we say? It was left? Which one of these numbers is on the left of that subinterval? 10. Your left hand makes the L. Okay. Plus. Next subinterval. Here, let me cover up everything except what we're looking at. From 3 to 8 is how far? 5. Good job. And then which is the number on the left? 12.5. Good job. Plus. All right. 2 more. From 8 to 10, what's the length of the subinterval? 2. And the number on the left? 17.5. Last one. What do you think? 6 times 28. Cool. What are you going to do to that? Nothing. Okay, that's it. Now, does it say anything else? Oh, under or over. Okay, look, because it's very visual. What is happening to these numbers? 10, 12, 17, 28, 46. Increasing. Just watch. All I'm going to do is draw something increasing. Now, just look. This is very visual. This is the left. This is the right. I don't know why, but after over a decade of teaching this, I learned that writing the L and the R works. I don't know why, but for people that couldn't see it, put the L and the R on there. We did a left sum. That is the smaller side. Do you see that? You see how this is lower down than this? It's okay. So we're going to say underestimate, and I ran out of space, so I abbreviated. Underestimate because f of x, and don't say it, no pronouns. They won't take that. You have to, and some of you learned that on your last test. You have to say f prime or f double prime. Because f of x is what? What did you tell me these numbers are doing? Increasing. I tricked you into already saying it. Underestimate, because the function f of x is increasing, and this is what? What did we do? A left sum. Left sum. My word ran together and it looks like left sum, so I'm sorry. Left sum. Underestimate, because f of x is increasing. I'm underlining the important words there. And this is a left sum. But that's valid. I agree with you, but I'm telling you, these are the things they're going to be looking for. Underestimate, increasing, left. Those are like the important words they're going to be looking for in your justification.
You said not to say what on the AP thing?
Don't use it or the graph. You have to say f prime or f double prime, like a name. Like instead of me saying like, he told me a story, I have to say Aditya told me a story. Like you have names are important. No pronouns. Mm-mm. They don't like that. They want a name. You want to call it f of x. Bless you. And again, to be clear, I agree with you, but I'm trying to tell you how to get all the points on the exam. I know, right? Well, actually, they stopped doing them in COVID and never started it back up. So I'd like for them to do it again. Yes. Mm-hmm. According to me, it's not. Hey, if I'm working this hard to send you in there ready, you're taking it. Also, and did we talk about this? You guys will get 2 scores. You'll get a BC score and an AB sub-score. And if you don't like your BC score, fine, but they're going to be fine. Your AB score can get you college credit. No, you'll get 2 as well. You will all get 2 scores. They're retaking, yeah. Okay, can we continue on? We're doing really good today, so I don't want to like lose our momentum. All right, use those same 4 subintervals to find a trapezoidal sum. You have to write it the long way because they aren't even. All right, look. Start all the way at the edge of your paper. Why did I put a half? You have to, because the formula said so. That's because it was in the problem kind of thing. All right, what is the length of your first subinterval? 3, good. And then you're going to put 10 plus 12.5. 1 down, 3 to go. Yay. All right, plus a half. And then what? 5. Perfect. And then 12.5 plus 17. I don't want to keep droning on and put you all to sleep, but can you continue writing it and I will too, and we'll just all make sure that we get the same thing? And can I say something about that next one? Do you see how there's a 1/2 and then immediately a 2? Write the 1/2 and write the 2. I get that they cancel or divide out, but it is pattern oriented. You do not want to leave off part of the pattern, okay? Yeah, I ran out of room and went down to the next line. That's okay. Yippee. Oh, you're doing so good on time today. Rock. This is like the best lesson ever. Okay. Because the back page, we got through like all the really heavy writing. This isn't going to be bad at all. All right. So what this all gears up to is a definite integral. Definite means that there's boundaries. Indefinite means that there aren't boundaries. We're going to do indefinite next time. Everything we've done so far are estimates for an area. They aren't perfect. You get that right? Like they're off by a little bit. A definite integral means it is the perfect answer. It means you have infinite subintervals. If that feels like a limit, good. Your subintervals approaches infinity. And we're going to talk about that on the other side of the paper. Okay. Infinite subintervals. And it looks like this. You've seen it before though. From A to B, f of x dx. I'm going to go over some things because the theme of this class is, oh, I didn't get that last year, but now I understand it. So I'd like for that to continue. The f of x. Do you remember how when we plugged into our function, our x squared, that's how we got our heights? F of x represents the height of your rectangles. Dx, that's delta x. A lot of you are in engineering. You know the triangle, the delta, the Greek letter means changing. Okay, that's the change of the subinterval. That's the base of your rectangles. So it's base times height. If you leave off a dx, you have left off half of what constitutes the area of a rectangle. It's that important. Do you get what I'm saying? Like the area of a rectangle is not just height, it's base times height. It's that important. You've left off half of your rectangle if you don't put a dx, okay? So let's write an integral to represent what we estimated on page 1. Look back at it. What are your boundaries going to be? Just flip back over. It's from where to where? 0 to 1. What was our function? X squared dx. I am going to share my screen and open up Desmos, and all I want you guys to do is watch. Let me get Desmos opened here, though. Sorry, that's my bad. I should have had it open, but I didn't, so it only took a second. Are we looking? All right, share screen. Come on. There we go. If I don't hit share screen, it won't show up on the recording. You guys will see it, but the recording won't have the calculator in it, and I want anyone that was absent to be able to see it. Okay, do you know how to type an integral into here? INT, very good. See how it shows up? I'm going to do 0 to 1. Hold on. You need parentheses. X squared dx. It came out to 0.333333333. What does that mean? 1/3. Hold on a second. Let me go back because this geeks me out entirely. I get that I'm a math nerd because I'm a math teacher, but the area under this graph from 0 to 1 is exactly 1/3. That's cool. You can disagree, but I'm right. That's cool. That's so cool. It's a third. That's neat. Neat, guys. Neat. And also, when you look at all those estimations, that's kind of why I gave you those decimals. You can see how close or far away they were from a third. Okay? Now, all I want you to do is set up an integral for these areas. We're just going to practice setting it up. We're not going to do anything else. So for this one, what would be your boundaries? Where to where? 1 to 5. Leave a big old blank for a second and put dx. Now, I'm going to see who remembers their algebra 2. Don't groan at me. We want to write an equation for that parabola. So first of all, is the parabola, bless you, right side up or upside down? So we need a negative. It's going to be something squared plus something. Why is it x minus 3? Because you are all right. Yeah, it went right 3, and then it went up 4. So bless you, plus 4. It looks what? Oh, did I fit it in there? All right, hold on. We're getting there. What are the boundaries, first of all? Negative pi over 2 to pi over 2. Leave a gap, put dx. Dx is super important. It is the base of your rectangles. I know, it's like, is it sine or is it cosine? What do you think? Why is it cosine? Because it starts at 1. I'm going to also type this one in. Can you all just humor me for a second? Because this one also geeks me out. Does anyone know what it is? We'll see. We'll see. Hold on. No, you're close. Hold on. It can't be 0. The area is obviously not 0. It's a positive area. You guys understand? Wait, hold on. Do you understand what we're finding? Like what this answer represents? It's the area that's highlighted there. All right. Can you all just be quiet and hold on a second? All right. So this is cosine x dx. And the answer is 2. That's cool. That's so cool. That's 2. That's so neat. The answer is just 2. Now, hold on. I'll make this bigger because I'm done with the calculator. Come on. Go to full screen. There we go. So this equals 2. If you look at this, that means this half of it is 1, and this half of it is 1, which is just a convenient thing to know. Just throwing it out there. If you have to find the area of, because that would work for sine as well. Do you know what I'm saying? It's 2. Cool. It came out to 2. Just 2. Neat. All right. We'll do C. We'll skip D. All right. We're going to practice writing an integral. Again, we're just practicing the setup here today. From -1 to 2. So we're going to be finding this area from -1 to 2. Now you're going to need two integrals for this. What are going to be the boundaries on the first one? -1 to 0, leave a gap, and we have to write that function. It's linear, so think y equals mx plus b kind of thing. What would be the equation for this line? X plus 1. Okay, that's what I thought you said. X plus 1. Plus, and now we're going to set up another integral. So what are the boundaries on the second one? Yeah, 0 to 2, leave a gap. What would be the equation for that one? Negative x squared, good, plus 4. Perfect. I'm just going to verbally go over this one. If you want to go from -2 to 3, just in case this shows up, you again have to write two separate integrals. And you would have to break it where? At 1. Do you understand why? Because of the whole. It's a discontinuity. Okay. Now this last thing, I copied this from the calculus standards on the College Board website. You can read it if you want to. Okay. But all we have to do is write each one of these as an integral. This will show up on the AP exam. This is how this shows up. Okay. It's not really that complicated. Did you do these last year? Oh, you saw it on the AP exam. Okay, well, I'm going to fix that, okay? Listen, do you see that limit n goes to infinity? That means we want an infinite number of what? Subintervals. That's our subintervals going to infinity. That's what that means. And then your generation has reclaimed this word, but what is that symbol? That's sigma. That means summation, which just means you're adding it all up. So listen, it means we want an infinite number of subintervals, and we're going to add them all together. That's all that means. Cool? You want an infinite number of rectangles, and you're going to add them all up, okay? That's all that means. We don't need that. Do you see how this is ln of blah, blah, blah? This is your variable. So inside of your integral is ln of x. That's it, Miss Cole? Yep. Now you have to get your boundaries. So listen, do you see this 2 that's inside of there? That's the start. So 2 is your lower boundary. And do you see, no, hold on, let me finish explaining it. Do you see how there's 5, but do you see how they match? That is your change. So your upper boundary isn't 5, it's 2 plus 5, just so. So that is your answer. Let's try it again. We want an infinite number of subintervals. We want to add them all together. I'm going to cover that up because we don't really need that. That's all that means. Do you see how it's 2 times blah, 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 blah? So your function is 2x. It's 2 times blah, blah, blah. So 2x. So -2 is your start. And then 3 is your change. So -2 plus 3 is, 1. Why did I say 5? Now, don't do the last one yet. This one's a little different. I will not conceal from you. I actually kind of like these. I think that's fine. I do not like this question. What about this one is not like the others? What did they change? Because they're evil. Well, there's a square root, but do you see how they don't match? See how those are 5s and these are 3s and they don't match? It is. They have to match. So the part that I can circle can only be 1 over n. And, 1k over n. So that part that I circled is what's going to represent x. So instead of square root of x, inside of your integral, it's going to be square root of, what do you think? I want to see if someone can, 1 plus 3x. They stuck a 3 in there for extra fun. Okay. Now, if I pull this part out of here, it's 1k over n, but what's your start? There's nothing else there. So your lower boundary is 0 and your delta x is 1. I don't like that question. I don't mind 10 and 11. I feel like those are pretty approachable. I don't like that one. But why do you think I put it on here? because I found one like that on AP Classroom. And I'm like, okay, if these are the people making the exam, I want my students to see it. I don't skip problems just because I don't like them. I'll complain about it and tell you that I don't like them because my feelings are valid. You know, I always tell you that your feelings are valid. But you are likely to come up against something like that on the AP exam, so that's why I showed it to you. Go ahead.
Why isn't it 1